All right, so today we're in section 7.2, percents and proportions. Probably the most important thing about this lesson is going to be your percent formula or your proportion, and that's A over B equals P over 100, or is over of equals P over 100. And the reason I have two different ones, they're actually the same exact thing, except the one on the left is my official variables. A over B, those are my official variables. The one on the right uses my keywords, is over of. You see down here at the bottom that my keyword for A is, my keyword for B is of, and P is percent. That'll make more sense in a minute when we start looking at these percent problems. But the proportion on the left is my official variables, A over B equals P over 100. The one on the right uses my keywords, so it's a reminder to me of what value goes where. My is value goes on top, my of value goes on the bottom. What am I saying by that? What does that mean? That means that my part goes over my whole. B is my total. You might even want to write that down. That might give you a clearer picture of which value is which. B is my total. A is my part. Okay, A is my part. And this is our basis for working every problem that we're going to work today. We're using the percent proportion. So in example 1, we're using the percent proportion to solve for percent. It says, what percent of 12 is 8? What percent of 12 is 8? So again, the very first thing we do is we start with our percent proportion. A over B equals P over 100. And I have to figure out of this question, this sentence, which value is my A and which one is my B. My keywords will tell me. Because 8 is attached to my keyword of is, I know that that is my A value. And because 12 is attached to of, I know that's my B value. 8 over 12 equals P over 100. And now what do you think you do? To solve our proportion, we have to what? Use cross products. 12P equals 800. Divide both sides by 12. And P is approximately 67%. So when you put this into your calculator and you divide, you find that it's a repeating decimal, right? It just keeps on going and going and going. Anytime you have a repeating decimal, you round to the nearest percentage, okay? I didn't say every time you have a decimal, okay? So a decimal like 4.2 or 6.25 or any decimal that terminates, that's fine. I'm not going to round that. It's only the ones that keep on going and are repeated. All right, make sense? You with me? All right, and then the next one is a lot of the same. I know that we've already, most of us have already done this problem, so we're just going to kind of go through and review. But what number would I plug in for A?
25.
25, because that's my is. What value would I plug in for B? 80, because that's my of. P over 100, do my cross products and divide. Okay? And that's going to be it for example 1. And then for examples 2 and 3, really what I'm doing is I'm just solving for different parts of the percent proportion. So in example 1, we solve for percent. And in example 2, let's read this sentence. It says, what number is 24% of 200? So in this, I know I have a percentage. So I have a P value. And 200, is that my A value or my B value? It's my B value. That's my of. Of is my keyword for B. So 200 goes for B, goes in for B. And then process of elimination means that what is left? What's left? If I know P and I know B, A is left. And that makes sense because it says what number is. So my variable is attached to my is keyword. So A is the variable that I'm solving for. All right. So what do we always start with? A over B equals P over 100. That's our basis. That's our baseline. That's what we start with on every single problem on your homework tonight that involves percent proportion. That's your original problem. You don't have to rewrite the question. Your formula is your original problem. Make your substitutions, okay? Go ahead and make your substitutions and then use your cross products and solve. Go ahead and do that. I'll give you a minute and walk around and check your work. Let's go ahead and just knock out both of them, all right? Okay, so you don't know A, 200 is B, and 24 is P. Did you get that? Okay, so we make our substitutions into the formula, and then we do our cross products. 24 times 200 is 4,800. Then 100A, divide both sides by 100, and A equals 48. A equals 48. Okay? All right, so on the second one, again, we're solving for A. What number do I plug in for, didn't mean to put all that up there. What number do I plug in for B? 315. What do I plug in for P? 56, which I messed up, so I got to go back. And then I get 100A equals 17,640. Divide by 100. Do I need to round this answer? Do I need to round it? No, because it's a terminating decimal, I don't need to round it. Now, if it went on and on and on forever and was a repeating decimal, then yes, I would need to round it. Okay, and we can just round to the nearest whole number. That would be fine. All right, any questions on example 2? The only difference is I was solving for a different part of the percent proportion. So guess what we're doing on example 3? Solving for B. We solved for P. We solved for A. Now we're going to solve for B. So there's really no difference except I'm just solving for a different part of the formula. Now, it clearly tells me in the title that I'm solving for base. But let's just pretend for a minute that I don't know I'm solving for the base. And let's read the word problem and look for the keywords that would tell me what I'm solving for. Okay, so let's read it together. It says, in a heptathlon, y'all see the keyword there that tells you how many events? Hep. Okay, so a heptathlon, we know a heptagon is 7 sides, so a heptathlon would be 7 events. An athlete earns points in 7 track and field events. Suppose an athlete earns 836 points in the 100-meter hurdles. This score makes up 16% of the total score. What is the total score? So like I said, we know we're solving for B, but what keyword do you see in that problem that would tell you I'm solving for B?
Total score.
Right? Total. We know that B is the total or the whole. So because it says what is the total score, I know that B is my variable. And another way you can look at it is they clearly tell you that 836 is only 16%. So that also tells you that 836 is your A value or your part. Y'all with me? Okay, so let's set it up. A over B equals P over 100. Okay, I want you to go ahead and make your substitutions. I know we've kind of talked about it out loud, but I want you to go ahead and try to plug in your numbers. All right, so we make our substitutions. 836 over B equals 16 over 100. That's my percentage. My percentage goes over 100 because, like we talked about on Friday, if it's an 80% chance of rain, which it was yesterday, right? How many of you it rained at your house? Did it rain? Yeah, it rained a lot. I know, it was like 80% earlier in the day and then 100% your yard flooded. Yeah, so, I mean, we have some flooding issues too because all we have is dirt basically right now. So, yeah, I mean, all this rain is kind of crazy, right? Like it's just rained so much that it's almost like our water table's higher. So anyway, a rain percentage is always out of 100, so that's why we put percent over 100, okay? Then cross products says, all right, 836 times 100 is 83,600 equals 16B, divide, and you get B equals 5,225 points. Here's what that means. If he earned 836 points in the hurdles, and that score was 16% of his total score, then that means his total score was 5,225. Do you see that reasoning, that logic behind it? Okay, so one more example that I'm going to have you guys do, and I really want you just to be looking at all these different scenarios. So the scenario really will kind of hopefully train you to recognize what you're solving for, because each one of these percent problems looks different depending on what variable you're solving for. What number is, that's your A. What percent, that's your P. And if it says of what number, you know you're solving for what? B, base. All right, go ahead and make your substitutions and solve. Okay, so we, again, start with our formula. A over B equals P over 100. Make our substitutions. We're solving for B. Cross products. Okay, so 105 times 100 gives me 10,500. 84 times B, 84B. Then what do I do to both sides? Divide by 84, and I get 125. So now let me ask you this, okay? And your homework problems are not going to necessarily ask you it in this way, but we can make sure that our answer is reasonable by just looking at the original problem. Okay, 105 is 4% of what number? That's most of it. Would you agree that 84% is almost all of it? Okay, so is 104 almost to 125? Is it pretty close in value? So I know that my answer is reasonable. For example, if I had this question and I thought my answer was 250, I said B equals 250. Well, if I ask myself that same question, my answer is not reasonable because 105 isn't even half of 250, right? So there's no way it could be 84%. So I would know that I got the answer wrong and I need to go back and check something. Very easy, quick way for you just to check to see if your answer is reasonable. Now I'm going to give you a proportion. X over 50 equals 60 over 100. And what we're going to do is we're going to create a real life scenario based on this proportion. A real life scenario based on this proportion. All right, I'm going to give you just a minute to think about that and then give you some leading questions that will hopefully help you pull it together. Okay, so let's think about it in terms of what each part represents. 50 represents what? My total. So give me a scenario where the total would be 50. Total students, total animals, total something. Write it down. Write it down. And then of that, 60% of that total would represent something else, some part of that total. So we could have money examples, school examples, sports examples. There could be all different kinds of examples, but that's your structure, okay? So just give me a scenario where these values would be represented. Then we're actually going to solve for X. All right, so read me some of your scenarios. What did you say, Wame?
A student will take a laptop. Out of the 50 results, he writes only one. He has 60% of the funds required. What is X?
Okay, that's probably could work. JC?
$50, you spent 60% on clothes. What is the amount you spent?
Okay, what is the amount you spent? And even you could take that a step further and say, how much money do you have left? Which would just be a little bit of subtraction at the end. Anything else? Anything else, guys? All right, so here's my scenario. Nothing special, but I said there are 50 students in a classroom. We know that 60% of them are female. How many students are female? Okay, so 60% of the 50 students are female. How many is that? So go ahead and plug in your numbers. You know, the X over 50 equals 60 over 100. Did we already solve? Did we solve? Janie, what'd you get?
Well, I have a question.
Sure.
So if you ended up saying like all of that at the end, say how many students are male?
And we're going to get to that.
Would you have-
Yeah. We're going to get to that. It's kind of along the lines of JC. There's just a little subtraction at the end. But that's the application part of it that I want to get to.
So you
That's
have to figure out female and
Yes.
masculine total.
Yes, exactly. Yes, Lexi.
36.
Yeah, there's 30 whatever, $30, 30 students, 30 laptop options, whatever you came up with, or $30 of the 30, I don't know what yours was, Wame. But yes, so you would go 100x equals 3,000, divide by 100, and the value is 30. So plug it into whatever scenario you created, and it's 30. Now, going off of Janie's question and JC's example, if we know that 60% is 30, let's say it was, a scenario where we want to figure out how many were male. Well, how do we know how many were male? Subtract what? 50 minus 30, and that tells me how many were male. 20. It has to be 20 because the total has to make up 50. All right, does that make sense? And just like with JC's example, if she spent $30, that means she has $20 left over. All right, and if you understand that, guys, that's everything you need to know for section 7.2.